Welcome to the Edupedia world. In this tutorial, we learn about solid design principle and we'll see how these are implemented in Java. Solid. It was introduced by Robert C. Martins, which is also called as Uncle Bob, and then it was under Agile Manifesto. The author of several books, example Clean Code, so solid principles are also present in this book. Solid stands for 5 principles. The first one is single responsibility principle, which stands for S. Then for O, it is open closed principle. L stands for Liskov substitution principle. I stand for interface segregation principle. D is for dependency inversion principle. Code becomes more testable. Remember, TDD is not about only testing, it's more important about the design. Apply smart. Don't do stuff just because of. Very important to see the context of program or code when applying solid. Geos on software advice with use of common sense. So basically, when we say solid principles, so just don't apply them for the sake of applying. See how your code is actually fitting in those principles. So this is the use of solid principle to write a smart code. Now let's see each of the 5 principles of solid one by one. So the first principle is single responsibility principle. It states that there should never be more than one reason for a class to change. Okay, and it was given by Robert Martin. SRP paper linked formed the principles of OOD. So that means a class should concrete on doing one thing and only one thing. So that means a class should have only single responsibility. That is, a class should be made for this single purpose. It is called single responsibility principle. Where this principle also, somehow relate with the cohesion, which also tries to say the same thing. So you can see this is an example. There is an interface modem and we do have 4 functions: dial, hang up, send and receive. So it is having 2 responsibilities. So you can say one is like to dial, hang up, other is send, receive. Then we have connection management and data communication. So these are 2 responsibilities for the interface modem. Let's separate these 2 interfaces because our principle says that every class should have single and one responsibility. So let's make an interface data channel and let's make another interface connection. Let's put send and receive in the interface data channel and let's keep dial and hang up in the interface connection. So that way we are actually implementing single responsibility principle over here. Fine. Now let's go to the second principle of solid, that is open closed principle. This principle says software entities, classes, modules, function, etc. should be open for extension but closed for modification. So this principle was given by Robert Martins, paraphrasing Bertrand Meyer in paper that was OCP paper linked from the principles of OOD. So basically this principle actually says that change a class behavior using inheritance and composition. So just to clarify it more, actually it means your code should be open for the changes but closed for the modification, or open for the extension but closed for the modification. That means if you want to extend your code, that is you want to add a new capability, then it should be open for that. It should be open for extension. But for modification, it should be closed. If you want to, change the existing functionality, it should be closed. Because you should write your code such a way that you should not you need not make changes in your code whenever a new requirement or a change in requirement happens. There should be least amount of code that need to be changed. Your code should be written in such a way. And in order to, make some changes, it should be open for extensibility. It should be open to add new code. Okay. So let's see example of open and closed principle. So you can see this is a bad example where we are having a class graphic editor and then we are having a method public void draw shape. It is taking shape class as a parameter, and then we have another class shape which is having int m type. Then we have two concrete classes, rectangle and circle. Both are extending shape, and in that we can see we are having constructor of these two. Okay, so in the method draw shape which is taking shape, so we are actually comparing if the type of shape, that is S dot M type, equals to 1, then we are calling draw rectangle, otherwise we are calling draw circle. And then we are having draw circle and draw rectangle method inside draw shape. So you see how it is, highly tightly coupled in a way that, in order to make any changes, we need to change a lot of our code. So this is actually a bad example. Impossible to add new shape, obviously, because if you want to add new shape, you need to modify the graph editor class, because if you want to add new shape, you need to, write one condition over here and then call new method over here. Then also you need to, like, creating a class, and that the constructor we have to write the super M type equals to 3 and so on. So there are a lot of changes we need to do, and we need to make changes in graphic editor. Whereas we should not, because this is our business logic. So if you want to just add on something, you should not change your existing business logic. Why so? Because if you do so, then your cost of regression testing would automatically increase, because you have to, again test the existing scenarios just to ensure that your test cases and your code is passing the regression test. So, it actually increases the efforts and the time. So that's why we should actually follow open close principle. Okay, and important to understand graphic editor to add new shape. Obviously, if someone wants to just add new shape, he has to go through the whole code of graph editor. Then there's a tight coupling between graph editor and shape that we can definitely see. Both are so much dependent on each other. It is difficult to test a specific shape without involving graph editor, definitely. I mean, you have to go through the whole code to test it. There is a if else case which should be avoided, because today we are having two, tomorrow we could have about 20 to 30, then we can't expect to write each to have a if else case. Okay, so the code will be like really lengthy in that case. So now let's see how this thing can be improved using a open close principle. So over here you can see we are having a class graphic editor, and we are having a method draw shape. In the method draw shape, whatever shape object we are getting, we are just simply calling draw method from that, and we are doing nothing else. Then we have a shape class, and then we are having a abstract method in that shape class. Fine. Then we are having a rectangle which is extending the shape, and then it is overriding the method draw. Similarly, we can have circle class which is extending shape and overriding the method draw. Now, whenever we get this shape S, depending upon which shape object we have got, either a rectangle or a circle, the draw method of that class will be called simply. So you see how the code has become relatively easy, and it's open for any new shape, but it is closed for any modification. Fine, so that was the second principle. And now let's go to the third principle, which is Liskov substitution principle. Well, this principle states that functions that use pointers or references to base classes must be able to use objects of derived class without knowing it. It was also given by Robert Martin, LSP paper linked from the principles of OD. Okay, and my translation for this principle would be subclasses should be behave nicely when used in place of their base class, or we could also say that subclasses should be able to substitute the functionality of base class entirely. Okay, so that means if a base class is able to do something and we are creating a subclass, then subclass should also be able to do all that functionality that base class was taking care of. This is an example, and you can see over here, actually it's an example to show the violation of Liskov substitution. So you can see we are having a class rectangle, and then we are having width and height in it. We are having getters and setters of the height, and over here we are having a method to create area. So this is actually simply multiplying width and height and giving you, returning you their area. And then we are having a class square which is extending rectangle. So you see in the class square we are having set width and set height method. So why it is violating Liskov's principle? Because actually it's not kind of reusing the setters and getters of rectangle. So you see that again, like we are setting m width and m height over here, and this class is not able to, completely replace or do exactly all the functions that rectangle classes was doing. So you can see over here, this is a problem. Like we are again setting m width and m height over here, although we are having setters for that in rectangle. So again, you can see there's a class LSP test, and then we are having rectangle equals to new rectangle. It can be an object returned from some factory where, like, it could be simply return new square. So any object returned by factory method. And we are having a main method, and this main method is actually taking the object from this class LSP test dot get new rectangle. So it is returning us a object. It could be square or a rectangle or a circle. Whatever it's returning, it we are getting it in R, and then in R we are actually doing set width and set height. Now user know that it's a rectangle. It assumes that he'll be able to set width and height as far as for the base class. Okay. And then we can do R dot get area. Now he's surprised to see that there is that the area is 100 instead of 50. Why so? Because you can see, like, it should be 50 because it's doing 5 into 10, but it will be 100 because in the class rectangle, what we are doing is when we are calling set width or set height, you can just, go through it again. Basically, we are setting both of it. So whatever the width we are passing, we are setting it, and we are also setting the height as well. And similar, the thing is we are doing for the height. So whenever the second parameter comes, that is 10, it will override the width that we have set previously, and it will make both of these things as 10, which will give us as area of 100. So you can see we are not properly implementing Liskov substitution principle over here. Okay, so that was the third principle from the solid principle. Now let's go to the fourth principle. The fourth principle is interface segregation principle. This principle states that clients should not be forced to depend upon interfaces that they do not use. Okay, it was given by Robert Martin. And just a simple translation would be keep interfaces small. That means, the client should only be forced to see or, depend upon the interface that they want to use, and those interfaces that they do not want to use should not be provided or, forced upon clients. So they should not be forced to depend upon interface that they do not use. So it's about just show whatever they need and just hide everything else. And keep your interfaces small, because if your client need to add money and to, like a bank application, if your client need to just add money and he's not in a need to take out the money, then you should have a separate interface which will just give him a functionality to add money, not to take out the money. So that is a concept. And it further says that don't force classes to implement methods that they can't. Okay. So means can't means they don't need to. Okay. Do not pollute interfaces with lots of methods, definitely, and avoid fat interface. Don't make your interface huge by putting lots of methods. If you think that there's a need to, perform lots of things, just try to think whether we can separate it and make two interface, because, they must be functionally independent. They should have just one purpose. So just, whenever you can see there are lots of methods, it could be possible that the first principle of solid, that is single responsibility principle, might not be followed over here. So just make sure that that is followed, and your interfaces should not be really fat. Okay, and this is a bad example. You can see a polluted interface. It is having an interface worker, and it is having a method work and eat. And then we are having a man worker which implements worker. So now for work, like man worker, it could be possible man worker don't need to work. Then now your man worker must need to implement the work method also, although it don't need, it just needed the eat method, that's it. So why to force man worker to implement work also? Okay, similarly we have a robot worker. For that, eat is not applicable. Why? Because it's robot, so only work is applicable for it. So the solution would be to split it into two interface, where we can say interface workable and interface feedable. So whichever needs to work can implement workable, and whichever needs to like eat can implement feedable, and since Java classes can implement more than one interface, so if there is someone who wants to do both the thing, so workable and feedable both can be implemented. Okay, so that was the fourth principle from solid principle, and now let's go to the last principle, which is dependency inversion principle. Fine. So this principle states that a high-level module should not depend upon low-level module. Both should be dependent upon abstraction. Fine. And point B is abstraction should not be depend on details. Details should depend upon abstraction. Okay, so again, it's given by Robert Martin. And the translation would be use lots of interfaces and abstraction. So the thing is, your high level module should not depend upon low level module. It should not be there should be dependency between high and low level. Rather, it both should be dependent upon abstraction. And your abstraction should not depend upon details. Rather, details should depend upon abstraction. So if you use interface and abstraction, you will see that wherever you need a dependency, you do have a abstraction for that, you do have a interface for that, and wherever like there's a interface or abstract class, you can see that your actually details are depending upon abstraction. It should not be like your abstraction depend on details. Fine, just to show you a bad example of dependency inversion principle. There's a public class employee service and there's a method private employee finder, EM finder. So the concrete class, not abstract class, can access SQL for instance. Okay, so this is something which can access the SQL DB, and then we have public employee find employee method, which is calling the another method find employee with the object of EM finder. Okay, now EM finder is the object of employee finder. Fine. So this is actually trying to call another method which is in another class. So you see how the dependency is done in this case. It's highly dependent. I mean, employee service is highly dependent on employee finder. In order to call that method, we first need to create the object of employee service, and then from the object we need to call this method, that is find employee, and within find employee another object of employee finder will be needed, which will be calling find employee. So you can see how complicated it is if we are not following this principle. And first of all, this is a private method, so it cannot be accessed outside the class. So that is a problem. Okay, so now it is not possible to change the finder to be able to be a XML employee finder. Okay, or DB employee finder or flat file employee finder. Why? Because we have simply fixed it in a way like in a class of employee service, and it is returning just find employee, it is just returning an employee object. So now we cannot in a way inherit it because it's just doing a single thing and cannot reuse it. So it does make it really fixed. Okay, so and we don't want that, because we want there should be a use of interfaces and abstraction in our classes, so that there could be a reuse of code also. So guys, yeah, that was about the 5 solid principles. I hope you have enjoyed it. And yeah, just try to implement this principle whenever you think of writing your code, because these are like really important. And even if you are like trying to study Java, or even you are trying to practice for the interviews, this is like really a very important question, that how you can implement solid principles in your code. So it is really important for you to understand these principles. As of now, thank you for attending this tutorial. Let's meet in the next tutorial. Thank you.